Thank you. I'm Mr. Lehner, and welcome back to Mr. Lehner's Math Extravaganza. In today's webisode, we're going to take a look at parallelograms and talk a little bit about how to find the area of a parallelogram, and a little bit of a tongue twister there, and the perimeter. Now, when finding the perimeter of a parallelogram, I have some examples up here. What you're going to do is you're going to measure each one of the sides of the parallelogram and then add them together. Very similar to our square, rectangles, and triangles that we've worked with through this workshop so far. What I'm going to focus on in this video is how to actually find the area of these parallelograms, as it'll be a little bit different than what we've done with the squares and the triangles. Well, let's not waste any more time. Let's take a look at these bad boys up here. Okay, I'm going to start with parallelogram B here on the side. Now, when I'm finding the area again, I'm trying to find the inside or the covering of this shape up here. Now, the one thing you might notice that's different is that, well, this is only part of a square, this is part of a square, this is part of a square, this is part of a square. Whereas with the square and the rectangles, we had full squares like this all the way across. So it's a little bit different than what we've worked with before. But I'm going to show you one strategy to start off. With parallelogram B, I like to call this like the slice away method. If I drew a line down right here, and I took this triangle, because this would then make a triangle here, and I moved it to this side here. So basically, if I had scissors and I cut down this line here, I took this triangle and I put it on this side, it's going to fit perfectly because they are equivalent. They're congruent triangles that fit in the same area. Well, now I have full square set up. And I can count and say that this would be 1, this base would be 2, and the height would be 1, 2, 3, 4. So 2 times 4 would be 8, and I would call it 8 centimeters squared. Because again, I took this triangle off here, I added on this side to make it into basically a rectangle with that. It had a base of 2 and a length here of 4. So 2 times 4 would be 8 centimeters squared. Now remember, it's a parallelogram. We're not dividing it by 2 like we did with triangles. That's the formula for a triangle. So this is one way. If this helps you see to slice a part away and move it to the other side, by all means try that one. Let's take a look at a second strategy. Okay, let's get ourselves set up again. Okay, I could look at this as a different way as well. So now, inside my parallelogram in here, I'm going to try and figure out how can I figure out the area. Okay, I'm going to draw a box around the outside of this figure. Now I know that this middle section right here is a rectangle. If I were to go like this, I know that this is a 1 by 4 figure, so I know that this area is 4 on the inside. Well, now what do I have left? I have a triangle here, and I have a triangle here. Now I can use these triangle figures to try and find the area of each side of these triangles. So I know this has a base of 1, 1, 2, 3, 4, a height of 4. 1 times 4 is 4, divided by 2 becomes 2. Let's try it on this side. It has a base of 1, it has a height of 4, so 1 times 4 is 4, divided by 2, that's 2. So now if I add it together, this triangle has this triangle has an area of 2, this has an area of 2, this middle rectangle has an area of 4, so it becomes 8 centimeters, a little bit off the page there, 8 centimeters squared. So again, this is the second strategy I used. In the first one, we sliced the part away. In this one, I broke it up. I decided to use shapes that I already have some background knowledge on. I already know how to find the area of a rectangle, which was a 1 by 4, which was 4, and I know how to find the area of triangles. So in this one, I decided to make this into a rectangle, a 1 by 4, and then I looked at just the triangle, which is the base times height divided by 2, and it's the same on this side. And then I just added up all my areas together to get 8 centimeters squared. Okay, what I'd like you to do at home is I'd like you to take a look at parallelogram A up here. And I'd like you to see if you can find out the area of parallelogram A using any strategy that you feel comfortable using. Go ahead and make sure you get your grid paper ready, your pencil to go, paper out there. Go ahead and pause that video. Alright, let's take a look at this one. A couple of different strategies you may have used to solve this. So I look at parallelogram A. You may have noticed that we can kind of cut away this side here. If I take this triangle and I cut it away, we're using the cutaway method here, I can actually add that triangle on over here. This has the same area as this triangle over here. They're congruent, so I can cut it away and put it here. Well, if I did that, I'd have a 1, 2, 3, 4. I'd have a base of 4, and base of 4 and a height of 1, 2. It becomes a 4 by 2 figure, so the area is 8 centimeters squared. Again, we're using the slice away method, so I sliced away this side right here, and I took that triangle. Imagine visually like you did it with scissors. You cut through, you grabbed it, you placed it here. Well, now I have myself a rectangle, right? Well, I know the rectangle, it's just a 4 by 2 here, so I multiply it and I get 8 centimeters squared. Now you may notice that, hey, that's the same thing as what we came up with in our first example for B. Even though these might look a little bit different, they're actually cover the same area. They're both 8 centimeters squared. Let's take a look at a second way to try that problem. Again, that was the cutaway method. Another way I could have done this one, make sure we're able to see it, is I could pretend it's a giant box around the entire figure. Now let's say I count 1, 2, 3, 4, 5. I'm going to say this is a 5 by 2. Okay? So right now I have 10 centimeters squared because I'm pretending this is a 5 by 2 rectangle. Now what you might notice is that, well, we don't have a full rectangle because this part's missing and this part's missing. Okay, well, what are these two things? Yeah, I know, you got it. They're triangles. We know the formula for finding the area of triangles, right? Well, let's find out what the area of those triangles are. So for me, I'm going to make this into a box. I know that this is a 2 by 1. So base times height, 1 times 2 is 2, divided by 2, 2 divided by 2 becomes 1. I'm going to do the same thing on this side here. Base of 1 and a height of 2. 2 times 1 is 2 divided by, 2 times 1 is 2 divided by 2 becomes 1. So now I'm going to subtract 2. Why am I subtracting 2 here? Because the area of this is 1, is 1, and this is 1, so I have to subtract it because it's not part of the entire parallelogram. So I have to take that off of my total. So 10 minus 2 would leave me with 8 centimeters squared. And again, just another strategy for trying to find the area of these parallelograms. Again, use what's most comfortable for you. I'm not going to force you guys to do it a certain way every single time, but try it out, and then whatever one clicks inside your brains and the light bulb starts to flash to go off, use that method. Thank you for tuning in to Mr. Later's Math Extravaganza. As always, we'll see you next time.